Okay, so thanks for sticking around for my session. What we're going to be talking about today, or this evening, I think it is in the US. It's actually morning in Australia. Is writing B2D style tests for ASP.NET MVC using MS Test Contrib, and really MS Test Contrib is really just a bit of an example. It's not necessarily the only B2D testing framework out there, but I'll talk a little bit more about that later on. Before we get started, a little bit about me. My name's Mitch Denny. I'm the Chief Technology Officer at Redify, and I live in Melbourne, Australia. This is Australia, and currently most of it's flooded, and the bits that aren't flooded are actually on fire. But you know, there are some benefits to that, in that I've got some recently acquired waterfront property at the moment. So I'm actually an ASP insider. And I'm actually formerly an ASP.NET MVP, although these days I spend a lot more time focusing on the ALM side of things. And I'm a fairly regular open source contributor. If you want to follow up with me after this presentation, ask any questions about what I've talked about, feel free to shoot me an email or follow up on Twitter. And I make semi-regular posts to my blog. So now with that out of the road, let's get on with the session. And the rough agenda that I want to follow today is, firstly, I want to give a bit of an abridged history of testing. Then, for those of you who aren't doing test-driven development, I actually want to do a bit of a primer. I won't spend too long on that, but it's important to understand test-driven development before you start to learn behavior-driven development, because it helps set the picture for it being an evolution of TDD. And then finally, I'm going to use MS Test Contrib, which is an open source library, to demonstrate some B2D concepts. I've got some time for Q&A at the end, but feel free to ask questions on the way through. I'll do my best to keep an eye on the Q&A section, and you know, I'm more than happy to be interrupted. Okay, so let's look at an abridged history of testing. If you want to do some background reading, there's a link there to a Wikipedia article, but the thing to take away from the history of testing is that it's widely accepted that testing has been divided into stages. And it goes a fair ways back. So, for example, the first identified stage of testing effort is what you call debugging orientated. Now, debugging orientated was very much about the developers doing debugging, and then testing wasn't really recognized as something that's separate. And that goes all the way up to what we call prevention orientated testing, which is really where we are right now. And we've been in that stage for quite some time. The debugging period for testing, as I said, was really software developers or programmers undertaking their own testing effort as part of the process of actually writing their software, just getting it to work in the first place. Now, what happened after that was that we saw the separation of the software developer role, or the programmer role, and the tester role. And during this period, we actually had to have testers demonstrating that the software actually met the requirements. As we move along, we started to come up with techniques for actively attacking flaws in software and trying to find those issues. So it wasn't just about demonstrating that it worked, but it was about finding the places where it actually didn't work. What were the boundary conditions? And this is where you get a lot of that sort of terminology arriving in testing, where you're looking for those conditions for failure. Then eventually we started to measure the software quality, and this is what we call the evaluation orientated period. And finally we get on to prevention orientated, which, as I said, is where we are now, where we're undertaking a lot of practices to try and reduce the pain associated with delivering poor software by actually eradicating the problems before we get started. Now, the conclusion I want you to draw from this is that if we consider that timeline again, the scale and the scope of the testing effort that we're actually undertaking has been steadily increasing. from when we first could identify, debugging as a testing effort. And so, in order to support that, there's been a diversity of techniques that have been developed. But the interesting thing is that way back in the beginning, developers started to apply this reasoning, which is testing is someone else's job. All right, we got past this debugging period. These people called testers came along, and all of a sudden we're trying to shirk that responsibility, if you will. Now that's actually a bit of a worry, because if you consider the cost of software defects, a lot of the issues that creep into software design early on in the process around requirements gathering and architecture actually have the most profound impact on maintaining that software in the future. This is actually a table from that Wikipedia article that I referenced earlier. And you can see that requirements and architecture problems have the most impact in post-release. And those issues obviously tend to creep in earlier on in the software development cycle. So really it's this section of pain that we want to try and remove. And so this is where we've got those diversity of techniques that we use to deliver software. And these are just some of the techniques that are fairly easy to identify in the software testing space. Now, as software developers, we should be all very familiar with the concept of unit testing, but there are all kinds of different testing techniques, all designed to address a particular area. So, for example, acceptance testing is a kind of testing we often apply later on in the development cycle if you're considering a waterfall model. Whereas requirements testing is something we might try to test way up front, and there's different ways of actually doing that. But this session very much focuses on the techniques surrounding unit testing and how we can actually improve the reach of unit testing techniques to deliver software. So now with that short abridged history out of the road, what I want to get on to is a bit of a test-driven development primer. Now, if you read anything about test-driven development, fairly quickly you're going to come across this red-green refactor and repeat mantra. The idea behind it is, with test-driven development, you truly drive your development process using testing efforts. So you write a test that doesn't work, you make the code pass or satisfy that test, and then you enhance the code to meet various maintainability standards. And you repeat that process. So red means write a test and watch it fail. Green means write some code to satisfy the test. And refactor means clean up the code to address non-functional concerns, for example, better maintainability. Refactoring is obviously an interesting one. If you take the precise definition of refactoring, you're actually basically just changing the internal structure of the code, not modifying the external functionality. I think that a lot of software developers use a more liberal definition of refactoring, and I think that's okay. I think that one of the nice things about TDD is that it allows you to evolve your API design to make it more usable. And finally, like I said, we repeat this process over and over, and in this way, testing drives the development process. All right, and that's why it's called TDD. Okay. Now, if you look at the structure of a TDD test, and we'll be jumping into some code very shortly, you really structure your test in three discrete phases. We have an arrange section, we have an act section where we actually perform the action under test, and then we check the outcomes. So if you look at well-written TDD tests, you'll often see these three sections. People will often put comments in the code to make it more explicit. Now, what I'm going to do is do a bit of a demonstration just to walk through the process of doing adding a feature TDD style. And I'm actually going to use the Nerd Dinner application, which is an awesome, well, it's a real-world working functional application, but it's also got a great code base, which is a good platform for demonstration. So hats off to the guys who built it. So let's look at the feature that I want to add. So as a nerd, I want to specify a dress code so that other nerds don't dress as Borat. Hopefully you all know who Borat is. So this is really a user story, and if you've been doing agile software development, you'll be fairly familiar with this common structure for a feature definition. And really what we're saying is that as some role in the organization, I want to satisfy some desire, and then we need to do that, and because of the context of this is why we want to do that. So what I'm going to do is jump into Visual Studio. You can see here that I have the Nerd Dinner application, and I've just downloaded that from Codeplex. It's a fairly simple application. It's got, from a structural point of view, it's got an ASP.NET MVC website here. I'm actually working on the MVC3 Razor branch for Nerd Dinner, not the actual trunk. So if you're looking for this code, just make sure to look in the branch folder. And you can see here that it actually has a nerddinner.tests project, and this is actually just a testing, MS Test testing assembly. And we can see here a range of tests which are actually associated directly with various classes within the codebase. Now, this is a fairly common practice with TDD in that you define a test which maps directly to an underlying class in the codebase. And that's one of the things about TDD, which is often a difference with BDD. Okay. So what I'm going to do is look at one of the tests here, and I'm going to write my first test to satisfy the feature that I defined earlier. So you can see here that the way the tests are written in this code base is that we define what we're actually doing against the API and what the post condition should be. And so I'm actually going to just cheat a little bit, and I'm going to drag in some code that I've written earlier. So if I drag that in, drag in a TDD test. So what I've got here is some code that arranges some preconditions. So for example, this application has a concept of nerd identity, so I'm creating a nerd identity. I'm going to use an empty set of data, so I don't need any data to perform this test. And I'm going to insert that empty data into a fake dinner repository, and this fake dinner repository is a dependency of the dinners controller. So we're actually in the dinners controller test, and so the class that's actually in the test at the moment is the dinners controller. Now finally, the dinners controller inside the application actually has a dependency on HTTP context, and so the guys who wrote Nerd Dinner actually decided to use the mock framework, and so I've got a mock controller context here, and I'm setting it up so that when someone gets the identity out of the user property, it will return the nerd identity which I set up earlier. Then finally, I go and act on that controller, and so I'm saying I want to create a dinner, and that will return a result, and then I have a series of checks against this code base. Now, in an ideal world, you tend to try and have just one assert per test, but often you'll have a couple just to help identify sources of issues from time to time. Now, if I try to compile this code now, it will actually fail. So the first step in any test TDD process is actually getting your code to not compile, is what it comes down to. And the reason it's not compiling is because the Nerd Dinner model for dinner doesn't actually have a property called dress code. Now this application uses the ADO.NET Entity Framework, and if I go into Nerd Dinner here and I look at the model, you can see that there's a dinner class here, but it's actually a partial class. It's actually getting most of its implementation from the Nerd Dinner EDMX file. So if I open that up, I can actually go in and I can add a property. I'll call this dress code. And what I often need to do with this kind of stuff is you update the database from the model. Don't need that. I hit compile, and hopefully my code should now compile. And then if I could go back to my dinner test, I actually need to kick it off. Now, what I probably should have done here before I actually started changing any code was actually run the unit tests. As I said, this is using MS Test, which is a built-in framework for Visual Studio. So I will select all of the tests and I'll say run. And we should find that at least one of those tests has failed. And that's because that's the test that I've already written. Even though I've started changing the code, I'm not satisfying the test condition yet. If I'd run these tests prior to making any changes, then all of the tests would pass, but we would have only had 68 tests. So what I need to do is figure out how to make this test pass. And if I look at the error, it's basically telling me that it expected the dress code to be smart casual, but the actual output was null. So this should be a relatively simple fix to make this code work. If I go to the EDMX file, I can select the dress code object. I can bring up the properties for that property, and I can actually set a default value. There we go. So now I'll just compile that to make sure it's all working again, and then I'll run the tests. Okay, we can see here that now all 69 tests have passed. So what we're seeing here is the typical cycle for test-driven development. It just so happens in this particular piece of code that I don't have a lot of refactoring to do, as the Entity Framework takes care of a lot of the heavy lifting for adding data to the actual application, although I would need to go through and add a representation of that data to the actual views within the application, whereas I'm focusing mostly on the API here. Okay, so let's jump back to the slides. Okay, so I started off by running the tests. I wrote my test, and in this case I cheated. I actually copied a lot of the implementation detail from other tests within that same code base. I compiled it and then fixed the compilation errors, and then running the tests again, they actually failed, and then I found the reason for that fail and fixed the failing test by fixing the implementation. And then if this code was more complicated or had some complicated domain logic, then I probably would have had to have refactored that code as well. So the nice thing about TDD is that it forces us to think about our API design. If you look through some of the tests within the Nerd Dinner application, you can see that there's actually a fair bit of consideration into the actual internal structure of the application. To give you a bit of an example about that, you can see here, this is the method name. Just by looking at the method name, you can tell a lot about the application. You can see here that they've got it's an MVC application. We've got an entity called Dinner, and they're dealing with a repository pattern behind the scenes to integrate with the back-end system. So TDD very definitely makes us think about the API design of our application, helps it drive it forward. The other thing that it helps us do is externalize dependencies. Because the code base needs to be testable, any external dependencies such as databases needs to be mockable. We need to be able to externalize those implementations so that during the testing cycle we can inject fake ones. And so you see a lot of IOC containers used alongside TDD development efforts. Okay, excuse me. So if we look at, this is an example here where you can see the class under test was the Dinner's controller, that we're actually injecting the external dependency. Okay. Finally, TDD enables us to embrace change. It's actually relatively easy for us to get cracking and add some functionality to software because we have a safety net of tests to protect us. If you're doing TDD and you don't end up with a whole bunch of tests, you're probably doing TDD wrong, and you can't have a lot of confidence in the changes that you're making to the application, in that they may well introduce more bugs. So definitely, when you're doing TDD, this is a good thing to see. The poor things about TDD is that I do wonder whether it makes us focus too much about the API. Are we all about just testing classes, or are we actually testing the functionality? And I think it's true that TDD definitely makes us focus on the API more, rather than the functionality that is presented to the end user. And to understand why that might not be such a great thing, you need to consider the cost of software defects again. If we're considering the API for your application, we're very definitely talking about the application architecture. And TDD certainly allows us to improve the application architecture, but it really only addresses the bottom 2/3 of this table. It certainly can reduce a lot of risk, but we're still leaving ourselves exposed to a fair amount of risk in the requirements gathering side of things. Are the things that we're developing a good match for the requirements, or are we just sitting there writing a test for an API that we thought was cool? And this is really where behavior-driven development helps focus us a little bit more on the functionality application rather than the API construction. Now, before I get started talking about B2D, I would strongly recommend that you go and look at this article by Dan North. The URL's there. I think these slides will be available after the presentation. This gives a really good introduction to how Dan North actually transitioned from being a TDD guy to realizing that B2D was actually something that we should be doing. This is, it very succinctly describes the evolution from TDD to B2D. And some of the things that he actually draws out are that a good TDD test uses sentences for method names. That is, they're describing some behavior in context. And they're very much focused on the behavioral aspect of the system. When the tests actually fail, because of that previous condition, the tests are actually very easy to identify in terms of what's wrong in the system. And so through this process, he discovers that B2D is more about the context in which you're testing and less about the API that you're driving. It's more about the description of the functionality and less about the actual code itself. So if we revisit our earlier requirement for Borat, we start at the specification. So when we're doing TDD, this is pretty much where we started. We took the specification and we started coding. With B2D, we actually think about it a little bit more. We take the specification and we accept it for what it is. It's a definition of the role, the desire, and the reason. But we actually start to break it down into the corner cases. Now, a good TDD developer will actually do this implicitly. They'll actually look at the specification and say, okay, well, here are the corner cases that I need to test for. But with B2D, we start to get more explicit about those corner cases. So we introduce this terminology called scenarios. Now, before I go too much further, I'll just say that every B2D framework has its own terminology. This is terminology that aligns with MS Test Contrib, but you'll see fairly common themes across the frameworks in terms of the kind of problems they're trying to solve with their terminology. So the scenarios that we're trying to cover in this particular specification is that because this is a change to an application that already exists, the default value that this thing returns should be smart casual. We should be able to change the dress code after the dinner is created, and we should be able to change the dress code at the time of creation. So they're the three scenarios that we want to be able to support to satisfy the specification. And then finally, if we just look at one of these, we need to start getting some idea about pre and post conditions. We're getting more specific now. And we're starting to introduce some language here around those preconditions. So given a user with access to create dinners, when a dinner is created, then the dinner created should have a dress code that's set to smart casual. So we've got those three steps in the execution of that scenario: setting up the preconditions, performing the action, and checking the post conditions. And this is very much well aligned with the arrange, act, and assert. So the point I want to make here is that B2D is just like TDD, but we've got some frameworks to help guide us in a certain direction. Okay, so this is the structure that you actually end up with in a code base. For each specification, you have multiple scenarios. The specification is like a user story. The scenarios would use terminology such as should. And then we have various steps or statements about pre and post conditions with the actions that are actually being performed. And then finally, once we actually get around to implementing this test, it's really the code is being attached to these steps. And so a lot of the B2D frameworks that are out there today allow you to basically define these steps up front and then incrementally add the code. And until that code is fully attached, then the test results are actually inconclusive. So now with that B2D primer out of the way, I thought I'd get with mstest-contrib. Now, mstest-contrib is not, well, it's a new lightweight B2D framework, but it's not just the intention is for it not to be just a B2D framework. Obviously, there's a lot of people out there who prefer other testing frameworks such as XUnit or NUnit or MVUnit. They're all great unit testing frameworks. mstest is actually a great framework as well. It is missing some features, and so there's a lot of open source developers contributing code to help augment NUnit. But I felt there wasn't a lot of people embracing and extending mstest. And so I wanted to have a contrib library for mstest which filled some of the gaps that mstest didn't support. And along the way, I realized that the true benefit of a library like this is that it can be a reasonable default to help teams get started. I would say that most people attending this conference are actually on the leading edge of technology. You're very much interested in learning new processes and practices, and so you've got no problems going and installing XUnit or NUnit and picking up any of the other B2D frameworks that are out there. But you have a challenge in that you've got to take your teams with you. And so sometimes if you've got an investment in a testing framework such as mstest, then it might actually be easier to use something like mstest-contrib to get people started. If you're happy using some of the other ALM tools from Microsoft, this makes a lot of sense as well, in that inside the lab management tools, mstest is basically the default test runner and pretty much the only test runner. And so using mstest-contrib, you can actually start to produce nice automated UI functional tests on top of the mstest engine using coded UI tests. So let's get started with a bit of a demo. So I'm going to be using mstest-contrib. There's a tiny URL to it there. But just before I get started, testing tools and testing frameworks, it tends to be one of those things that polarizes discussions. So I'm sure there'll be lots of people. I've got a question there. Let me pick that up. Can it's mstest-contrib. No, it cannot work with NUnit. So mstest-contrib explicitly takes a dependency on mstest to integrate with its results output window. If you're looking for something that's a lot like mstest-contrib in terms of the structure of the tests, I'd recommend looking at StoryQ. StoryQ is actually a great testing tool, and it's actually one of my inspirations for mstest. But I just wanted to take that and have some direct integration with mstest. So hopefully that's answered the question. Is that what I've got to do? Just got to tick the box there. Okay. All right. So with that, there are some other options. I'm showing mstest, but if you're looking for options which might be more appropriate for you, here are some search terms for Google. StoryQ is actually my preferred one out of all of these, and I think everyone who writes a B2D framework should actually be able to cite someone else's framework that they thought was pretty good that they would use if they didn't have their own to use. So most people prefer to use their own. mspec is also quite interesting. I find that it's fairly interesting to read because it uses a lot of Lambda expressions inside the classes. And I think that it's an interesting use of the C# syntax. SpecFlow is also worth a mention here in that they have, and there are a few others that do this as well, it has a really nice natural language version which will translate natural language into the underlying B2D tests, which is useful if you've got to integrate people like BAs into your teams, and you don't really want to have to teach them how to do any C# coding. But I think there are some natural limits to that kind of approach as well. So that's why I like StoryQ, and that's why I implemented MS-Test to MS-Test contrib as well, in a certain way. Oop. Let's jump back a little bit. So what I'm going to do is jump back into Visual Studio. I'm going to look at the same application, and I'm actually going to add a specification. Now, the way that MS-Test contrib is integrated into an application is via the package manager. It's actually posted up as a NuGet package. So what I'm going to do is I'm going to bring up the package manager console, and I'm going to select the nerd dinner tests, and I'm going to say install package MS-Test contrib. And that will go off to the central NuGet server, and it will pull down the latest version of the package, and it will attach that to the nerd dinner test. Now, this really only needs to be added into test projects, nowhere else. What that has done is, if I look at the nerd dinner tests, is add the MS-Test contrib library, and if it wasn't referenced already, it's actually added the Microsoft.C# assembly as well, and I'll talk about the reason for that a little bit later on. The next thing we want to do is add a specification which describes the behavior. So a lot of the BDD frameworks will use the word behavior and specification interchangeably. MS-Test contrib uses the terminology specification, but it really describes the desired behavior in the application. So what we do is we go and add a plain old test to the application, and we'll call this, I'll just leave it unit test 1 for now, I'll rename it in a second. In order to use MS-Test contrib, what we do is we actually subclass the specification base class, and we decorate our normal test with the specification description. So I can say, as a nerd, I want to set the dress code for a dinner so that other nerds don't turn up dressed like Borat. Next, let me just check that. Next, we actually decorate the test method. So this is very much relying on the MS-Test plumbing here. So if you look at the MS-Test contrib code, it's fairly light in terms of its implementation. If we look at the scenario description, should default to smart casual. Okay, so that's the scenario that we want to have to support. And I often name the actual method itself something similar to the actual description that's in there. Should default to smart casual. Now that we've got that specification level and that scenario level defined, we actually go in and we can start defining our preconditions, actions, and post-conditions. And by virtue of the fact that we subclass the specification class, I can go given a nerd with access to create dinners, when a dinner is created, then the dress code should be set as smart casual. Okay, so it's just a plain text description of the functionality that's required in this particular scenario. Now what I can actually do is go in and fully implement that. Now, the way that MS-Test contrib works, and the way a lot of the test frameworks work, is that they allow me now to specify a lambda expression following this plain text description. But before I do that, I actually just want to run this particular test. Now I've added it into the system. Okay, and it's failed because, and I'll probably should run that without the debugger there. It's failed. The test has actually come back as inconclusive. And if I double click on this, this is the nice thing about the MS-Test integration, and people who are used to using MS-Test will expect this, is when I double click on that, it has a plain text description of the scenario that's actually under the test and what particular features have the issue. So I can very quickly look at my test case and say, well, this is the area of the code base that's got the issue. What I'm going to do is I'm actually going to just replace this test code here with an entirely new class, just to sort of fully specify the example. So what you would actually do is fully flesh out all of the various scenarios that you've got that we've defined earlier, and then you actually go through and start doing the implementation. Now when it comes to implementation, I'll drag out another example of the code. All you're doing is simply using these Lambda expressions to, I guess, expand out on the functionality. And what you'll find is that you'll realize through this process that your code actually has a lot more preconditions than you first expected. And you've got a couple of different options here. What you can actually do is collapse a lot of these preconditions into a single method that you call into, or you can try to spell them out explicitly. I guess which way you go is really just a function of what your personal preference is. Given the time, I would often break it out into a separate method. And you can see here that in some cases I've actually created methods to set up the mocking, because the mocking for code is actually somewhat involved, and I would actually require a whole bunch of preconditions here to set that up, and I think it would mess up the specification. Now I'm actually going to run this test. So now let me go to my test view. And when I run this test run is empty. Let me refresh this. Okay, the test is run. It's actually failed. And the reason it's failed is that, this is one of the nice things about mvcconfmitchdenny as well, is that it's telling me what's worked down here. But it's also telling me where some exceptions occur, so I can go down here and look at more exceptions. Now, if I drill down in on the detail here, it's actually telling me that in this particular case, and I know this from experience, that the repository for the dinners actually contains two elements that have the same ID. And in going through this process and writing the specifications for this code, I came up with an interesting question. The question I came up with was, what's more correct? Should the repository check for the ID duplicates, or should the controller check for the ID duplicates? And this is an example where BDD framework, like TDD, actually starts to make us ask design questions about the code. Now, I don't know what the correct answer would be here, but it's possible that if we were designing our code base so that the external dependencies like databases could be changed at deployment time, well then it might be better for the responsibility for doing ID checks to be in the controller. If we're only ever going to deploy on something like SQL Server with Entity Framework, well that's probably acceptable to let the repository handle that responsibility. And then just depending on the outcome of that conversation about design, you would actually change your tests or introduce another test. So in this case, I'm actually going to change the test, so I'm just going to work around that bug for the time being. And the workaround's quite straightforward. I'm actually going to create the fake dinner using the technique I previously used, but I'm actually going to just generate a dinner ID, and that's actually had the result of simplifying my code base for the test a little bit. Now if I go back into my code here and I run this test, that should actually pass quite happily. Fantastic. Okay, now if I decided that, hey, maybe the controller needs to, excuse me, handle the ID detection, this would then drive me to go and add another test. Just replace that with some previous implementation. So I would actually go through and I would create a specification that, as a nerd, I should not be able to input a dinner with an ID that already exists, because this might impact the site stability and integrity. Now, what I've done here is I haven't provided the implementation of this test because obviously that would require a little bit more change to the actual mvcdinner code base, but I've actually created the test, and so now that would be actually added to our test run, and the results of this would be inconclusive until we actually decided to address that particular issue. And that is, in essence, a 101 on MS Test Contrib. Before I move off that and start to wrap things up a little bit, I wanted to look at a particular feature of MS Test Contrib which I felt was quite useful. And if I write a lambda expression here, I can actually, the value of x here is actually the specification context. And if I look at the properties for specification context, I get access to the what I call grammars, which are already created against this scenario. We get access to the scenario description, we get access to the specification object, and the actual underlying MS Test context. But we also get access to this object called state. And if we look at state, its type is actually dynamic. One of the things that you're going to want to do when you're doing BDD is keep track of various buckets of state. Now, without this state object, you've actually got to create field level values or actually local variables to keep track of state. This gives you another option in that with this dynamic object, I can simply go first dinner. Because it's dynamic, it'll let me do that. First dinner equals fake dinner data, create dinner, like that. And so I can actually just keep track of buckets of state. I can say the second dinner equals fake dinner data, create dinner. There we go. And then I could go through and provide my implementation for this particular piece of code. Which leaves us with one question, which is how we handle exceptions. Now, currently in MS Test Contrib, you don't have anything like a fails method that you put after that. That's just where the API is at the moment. What you actually need to do is, if you need to handle an exception in an action or a post condition, then you actually need to call out to another function, and you just do the try catch inside that to handle the errors and store it on the context. But the key point I wanted to show you here was how you can actually store random buckets of state on this object. There's some pros and cons to this approach. One of the poor things about it is that once you get down here and you want to use these objects, you don't get very much IntelliSense. So you're really dealing with a dynamic object. But on the bright side, you can actually start playing around with your API without having to implement that API at all, because that test will actually just fail, but it will still compile, which was one of the issues with TDD, in that you actually have to provide the skeleton of your API for it to even get to the compilation state. So there's good and bad things about this particular dynamic object approach. Okay, so let's jump back to the presentation. Okay. So one of the things I want you to take away from using MS Test Contrib is that the actual intent of the test is actually a lot clearer. We're describing it in plain English, and when those tests fail or they're not completely implemented, it gives us a plain text description of what's going on. It definitely exposes a lot of the complexity of dependencies. When you're doing test-driven development and you're just working in the arrange section of your test, you can tend to build up a fair amount of scaffolding code without really having to think about it. A lot of BDD frameworks make that scaffolding code much more visible in terms of the expressions that you have to write. And the downside of this is that the expressions can get quite unwieldy. And so if you do find yourself in that situation, I would recommend collapsing those preconditions into a subroutine that does a lot of the work to simplify things. And the nice thing about that is that those setup routines actually become reusable. The specifications really complement the test, so I'm not suggesting you use BDD over TDD in all cases. There are some bits of code, low-level APIs, socket-level programming, where TDD makes a lot of sense. we're describing the functionality from a behavioural point of view rather than the boundary condition point of view. It can sometimes be easier with a T2D approach and not use a B2D framework. And so the nice thing about mvcconfmitchdenny is it allows you to fairly easily mix and match the approaches with testing effort. B2D definitely works well at the controller level with ASP.NET MVC, and it allows you to focus on those functional areas within the application rather than focusing on your API. So before I open it up to Q&A, a few final thoughts. Testing's actually your job. Back in the beginning of the great split between developers and testers, developers did testing as part of the debugging process. With T2D and B2D frameworks, it's now possible for us to address design and requirements level issues as part of the development process very early on as part of our debugging. It helps us drive our development forward. So it's really time for us to claw back some of the responsibility for testing inside software development. And the key takeaway is if you aren't doing T2D right now, if you aren't doing T2D right now, start doing it. And if you are doing T2D, consider evolving to B2D. And thank you. How we go?
All right, thank you for presenting. Any questions, anyone? We have about 9 minutes before the next presentation, so plenty of time.
So if you do have any questions that you think of later, my email address is there, and you can feel free to get me on Twitter. It might actually be just as a bit of an experiment. It might be worth just asking how people actually do their testing. So. Type this up. We do TDD, we do BDD, we leave it at that. Okay, so let's change to that particular survey. Okay, well this is awesome because a lot of people are doing T2D. There's a few people who don't do testing. It's someone else's job. It's a bit of a concern, but that's it's not surprising. It's an attitude that crept into the industry fairly early on, and I'd actually be interested in some of the arguments around why developers shouldn't do testing, because I think there are probably some interesting conversations to be had there. And there's only a few people doing B2D. I'd also be interested to know what the spread of testing frameworks that people use. So I'll try and be as exhaustive as I can. So what are some of the testing frameworks that you're using? What's your principal testing framework? Wow. Okay, so obviously NUnit is definitely the dominant framework, and then we have slightly less than half of people of that using MSTest. So MSTest is is probably the second most popular framework, certainly according to this audience here. I know a lot of people who use XUnit as well, so I'm surprised that doesn't have a great showing, but the stats are actually kind of interesting there. I might take them away with me. There's actually a few questions there, so I'll jump to those. Manage, okay. Do you find stories and code diverging from the main list of stories? How do you keep them in sync? I guess I probably need to understand the question a little bit more, but I'll take a stab. So I'm assuming that you're talking about stories that might be entered into some sort of requirements management system. So if you're using something like TFS or Agile Zen, obviously you type your stories in some way to prioritize them and plan them, or on your task board, for example, on your Scrum wall. It's very easy for those stories to get out of sync with the code base, but what I think that I think the trap that people walk into is that they actually go start changing stories on the task wall. Whereas what you should probably do is create a new story on the task wall and decide whether to remove the previous story, and when you do remove the previous story, go and delete it from the actual code base. And if you use a BDD framework, then that makes it a little bit easier to find that story, because the fact that you have a single specification that describes that set of functionality and all of its scenarios means that you can go to one place and just trim it out. Whereas in a TDD approach, because the test classes tend to be associated with individual classes within the framework, the logic to support that particular story might be scattered across multiple code bases. I hope that answers the question. Another question is a statement used both MS and NUnit. That's great. I'm glad to see people using MS Test. I actually think it's quite a good framework. It's got some very good capabilities. Should ask about Test Runner, MS Test, or ReSharper. Yeah, I'll bring up a survey for that. So let's. It's interesting. We're learning from each other. So what Test Runner do you use? So we'll go MS Test. We'll go ReSharper, TestDriven.net. So this is a survey about what test runner you actually use to run your tests. A lot of people use ReSharper. I think one of the reasons that people avoid the MS Test runner is that there's a concern around performance, and the ReSharper test runner is actually very good. TestDriven is very good. One of the performance issues that you'll get with MS Test is that if you don't turn deployment off, then it spends a lot of time copying files around. Although it's still true that the other test runners are faster, so it's not terribly surprising to see those results. And obviously, when you're talking about agile software development, then the test runner speed is very important. Okay. What do I see as the future for fitness? I don't know if I'm qualified to answer that question. It'll be up to the contributors to that project to decide what they want to do. I think the interesting thing about the .NET community these days is that we're spoiled for choice, and so people tend to have their own pet projects that they use because they make a lot of sense for them. That's ultimately why a lot of open source projects get started. So I think that for as long as it's useful for the people who are willing to contribute to that code base, then I think it's going to be around. I think that's going to be true for MS Test Contrib and SpecFlow and everything. Do you have any advice to who is starting to... Let me actually share my screen here. And I'll bring up the Q&A. Do you have any advice to who is starting to use BDD and have some resistance to manage the huge amount of stories? I think that you probably need to look at what you're going to gain. I think with BDD, you can actually avoid having to write a lot of test cases which are unnecessary. Because it focuses you more on what's required to support the behavioral characteristics of the system and less about the API, you might actually end up writing less tests. And so I guess you can apply those time savings in other areas. But at the same time, I still say that there are some cases where a TDD-style definition of a test is useful.
Hey, I just want to point out that the other meeting is starting in approximately 1 minute. Okay. The live streaming the finale of the day, so.
All right, I'll happily take emails on these questions if you want to send them to my email address, and I guess I'll see everyone over in the in the finale. Unless, are we able to keep this stream open if people want to stay here? I'm happy to shut it down if.
Yeah, I'll tell you what, I'll keep the recording going until it's clear that there's nothing happening here, and there's always the IRC that's still on, so you guys can also use that as well.
Okay, fantastic. Okay, so I'll keep answering the questions as best I can. This is a question, but a comment. This looks really good, and I'm definitely going to try it out. That's fantastic. If you do try it out, please log bugs and request features, because I want a framework that's really easy for people to pick up and run, particularly if you're a leader of a team of people using MS Test. I would like this to be a reasonable default for MS Test. Can you handle UI testing with MS Test Contrib? You can, so there's no reason that you couldn't actually drive something like Watton or the coded UI test inside Visual Studio with MS Test Contrib. It doesn't impose any limitations around the UI. Can B2D be useful for identifying bad logic in the requirements phase where two stories might be contradictory between themselves? It's an interesting question. I think that it can, but I find that a lot of these things, and this is probably more of a comment around large projects, the bigger the requirements base is, the less likely it is that there's going to be enough shared information in one person's head to detect those fallacies in logic. I think that by implementing B2D, you might be weighing the chances in your favour, but I couldn't conclusively say why. It's a bit hard to explain. I think I think that the way that I guess it applies to storytelling. B2D is much more about telling the story, and I think as humans we tend to store information better when it's explained as a story. We're trying to use SpecFlow. Where does that fit in your survey for BDD? Have you used it? It seems to make it easy to create spec files for non-developers. Yeah, so I have used SpecFlow, and it's actually a really good tool. I think they've done some really clever stuff there. SpecFlow is it's a tool that layers on top of your testing frameworks, and so I think it's certainly true that the grammar for describing tests is easier for non-developers in that you don't have all this sort of strange syntax. But I think that creates another challenge in that when you do want to be very concise with what you describe, you kind of need to learn another language, if that makes any sense. Now, it might be closer to plain English, which is a benefit, but it's still a structured language. But SpecFlow is an awesome tool. I actually think those guys have done a great job. Like I said, I think SpecFlow is a great tool, and it layers across other tools as well. I'm not sure whether it could be used with MS Test though, so I'd have to check up on that question. So I might post something about that on my blog.